we're going to be talking about is the orbital diagram and electron configuration. And so I went ahead and wrote what the off-ball diagram is. We're going to be using this to help draw the electron configuration and orbital diagrams. Now, eventually I'm going to get you guys looking at the periodic table and how to do it without actually having to use this off-ball diagram. So if you've noticed, it says 1s, 2s, 2p, 3s, 3p, 4s, 3d. That is always going to stay the same. So if you've noticed, I've kind of drawn them out for you. Eventually, I'm not going to give them to you because I expect you to be able to follow the off-ball diagram. Okay? And so what it is you have to go through 1s before you get to 2s. Once you go through 2s, you're going to hit 2p, 3s, and it's going to be so on. So it's always going to follow this order. All right? Now, I've given it to you for the first four, but there's a multiple things that you have to do. First, you have to be able to tell me how many electrons an atom has based on protons, assuming it's neutral. Well, let's go ahead and look at hydrogen. Hydrogen's atomic number is 1, which means I have 1 proton. In a neutral atom, if I have 1 positive proton, I have to have a negative electron. That gives me an overall charge of 0. So when I go back, because I have 1 proton, I have 1 electron. So what Hund's rule, or what's off-ball principle is stating, okay, where is it at? Off-ball's principle, electrons occupy the lowest energy orbital available. So it's always going to fill 1s before moving to 2s. It's going to fill 2s but going to 2p. The other rules you need to follow are going to be Pauli exclusion and Hund's rule. And we're going to come back to that after hydrogen. Okay, so hydrogen has 1 proton, so it has to have 1 electron. And we show this electron by an up arrow. Okay. Now, it only has 1 electron, so 1 arrow is all we need. So how we write this in electron configuration is we're going to say 1s, and then you're going to use this subscript or superscript, and you're going to put 1 because it only has 1 arrow in this orbital. Okay? And so for hydrogen, it's pretty simple, and I'm going to keep it that simple for now. Okay? It only has 1 electron, so it's very easy to write out. For the next one, lithium. Well, let's go ahead and look at lithium. Lithium has an atomic number of 3. So if it has 3 protons, it has to have 3 electrons. Okay? And so I'm always going to start with an up arrow. But now I need to understand the rules. Okay? So Pauli exclusion's principle, there's no 2 electrons can have the same 4 quantum numbers. So there's only 2 electrons per orbital, so that means I can only have 2 arrows per line. And the electrons in the orbital must be opposite spin. Okay, so going back, I put an up spin, so now I'm going to put a down spin. All right, well, I need to put 1 more. So off-ball's principle says because I filled my 1s, I can now move on to my 2s. And so I'm going to go ahead and put an up spin. And now I've placed my 3 electrons, so I'm done. So now I'm going to go ahead and do the electron configuration. So I'm going to put 1s. I'm going to use the superscript 2 because I have 2 electrons in there now. And then I'm going to go ahead and put 2s, and I only have 1 electron, so I'm going to put 1. So that would be my electron configuration. 1s2, 2s1. Okay, and so if you guys are confused as to why we're doing this, just think of them as coordinates, okay, on latitude versus longitude, except now we're talking about areas around the electron that it's probably going to be. So this kind of helps you map out where electrons are, okay? So for oxygen, okay, I've given you the atomic number 8. So if I have 8 protons, I have to have 8 electrons. So once again, I follow the same principle. I'm going to go up arrow, down arrow. I've placed 2 electrons. Now, off-ball's principle states I can go to my next energy level. So I'm going to go up arrow, down arrow. I've placed 4, so I have 4 more electrons to place. But this is where you have to focus on Hund's rule. Electrons will occupy the same energy orbitals so that as many possible spins are the same. Okay, so the same spins. So what I'm saying is you have to fill every orbital with an up before you can place any downs. Okay, so this is what we want, all up arrows. Then if we have enough to place down, we go to my down arrows. Okay, so I have 4 more electrons to place, so I'm going to place up, up, up. Then I can place my down. Okay, so I've placed 8 total arrows. Now I'm going to go ahead and put my text. So it's going to be 1s, 2, 2s, 2, 2p, 4. Okay, because I only have 4 in the orbital diagram. Okay, so what I want you guys doing next is go ahead and do scandium, potassium, and krypton, and they're all on the periodic table. So you can use ptable.com. Okay, so you're going to use krypton, you're going to use potassium, and you're also going to do scandium. Okay, so go ahead, and when you're done, go ahead and submit your answers in Google Classroom. I'm going to give you guys the answers during class, and so I'm probably going to have you guys doing this when we're in class together. So if you're not in class, you're going to miss if you're doing it correctly or incorrectly. Okay, so go ahead and try this now.